Hello and welcome back to day 2 of coordinate geometry. So we are going to be adding on a little bit and then incorporating what we talked about last time to apply it in a new and improved way. So the first thing we're going to do is introduce new formulas, and these formulas are very straightforward. We're just plugging in values, and on the test they will be provided. You just need to know how to use them. So the first one is our distance formula, and we use distance formula when we're given 2 points. So if we have x1, y1, and x2, y2. We can find the distance between those 2 points on the graph by plugging in those x and y values to our distance formula. So let's practice that. We want to find the length of all 3 sides of this triangle here, DEF, if my camera will focus. So let's find DE first. So side DE. So I'm going to let this be x1, y1, and let E be x2, y2. And we're going to plug in those values exactly as they are in this formula. So x2 comes first, so that's going to be 5 minus x1, which is 2. So 5 minus 2 squared plus y2, which is 7, minus y1, which is 3 squared. Okay? So the first step is plugging in our values to the correct place. Then we're using our order of operations, PEMDAS. So we go with what's inside our parentheses first. So 5 minus 2 is 3. And 7 minus 3 is 4. So we're going to have 3 squared plus 4 squared. Now we apply our exponents. So that's going to be 9 plus 16. 9 plus 16 is 25. The square root of 25 is 5. So DE is 5. D and E are 5 apart. Let's do side EF next. So E is already x2, y2, so I'm going to make F be x1, y1. And let's find EF. So again, plugging into all of our spots, y2 minus y1 squared. Actually, I did that backwards. We need to do x2 minus x1. I started getting ahead of myself like slope. We do y first. So x2 minus x1, 5 minus 9 squared, plus y2 minus y1 squared. So we go with what's inside our parentheses. 5 minus 9 is negative 4. 7 minus 4 is 3. Negative 4 squared is 16, 3 squared is 9, and again that gives us a square root of 25, which is 5. So EF is also 5. Okay. And last but not least, let's do side DF. So now one of these needs to become our x2, y2, so I'm just going to change D. And we're plugging these into our equation, again, our formula. So x2 minus x1 squared plus y2 minus y1 squared. So 2 minus 9 is negative 7. 3 minus 4 is negative 1. 7 squared is 49. Negative 1 squared is 1. So this gives us the square root of 50. Now 50 is not a perfect square, and we don't want our answers in decimals. So we are going to leave this as the square root of 50. So if it's not a perfect square, leave it alone and leave it under the radical. All right, so that's our good practice with the distance formula. We are now going to move on to our next formula, which is the midpoint formula. So again, if we're given 2 points, our x1, y1, and x2, y2, we are just going to plug in those values and solve. And this is giving us a coordinate point, okay? So starting here with A, I'm going to plug in x1, y1, and x2, y2 to my midpoint formula. So that's going to be 1 plus 9 over 2 and 3 plus negative 5 over 2. 1 plus 9 is 10. 3 plus negative 5 is negative 2. So our midpoint is going to be 5, negative 1. That's the location on the graph. Another way we can use this formula is if we're given the midpoint and an endpoint, we can find the other endpoint. So I'm going to show you how to do this algebraically first, and I apologize, the formatting on this did get messed up just a tad. So what it's saying is our midpoint is at negative 2, 1, and the coordinate of A is at negative 5, 4. So let's find the coordinate of B. Now remember, we found this midpoint by using our midpoint formula. So that midpoint, negative 2, 1, came from x1 plus x2 over 2 and y1 plus y2 over 2. So if A was my x1, y1, this came from -5 plus whatever x2 was over 2, and y1 plus whatever y2 was over 2. That's how we found that midpoint. So we can use algebra to solve for this x and y value. So our x value was -2. So that would be equal to our -5 plus x2 over 2. And I can use algebra to solve for x2. First, I need to get rid of that denominator, so I'm going to multiply by 2 on both sides. And then I just need to add 5. And so our x2 value is +1. Now we can do the same thing with our y expression. Our y value is 1. And again, we first get rid of that denominator. And now I need to subtract. So our coordinates for B are 1, -2. That's how we can find it algebraically. Another way we can find that is if we use our graph. So if A is at the location -5, 4, I'm going to graph that. Here's A. And our midpoint M is at the location -2, 1. So M is in the middle, so it's equal distant between A and B. So let's figure out how on the graph I would go to the right and down to get to M. So that would be 1, 2, 3 to the right, and 1, 2, 3 down to get to M. And remember, M is the same distance away from B, so if I repeat those steps a second time, that will get me to the location of B. So let's go to the right 3, 1, 2, 3, and down 3, 1, 2, 3. So that would be B. And those coordinates are 1, -2, which is what we found when we did it algebraically. So 2 ways to solve that type of problem. Okay. Now we're going to talk about how to write the equation for a median in a triangle. So we have a list of steps, and if we follow those steps, this really isn't as tricky as it seems. So the first thing we do is find the midpoint of the opposite side. Recall that a median goes from the vertex to the midpoint of the opposite side of the triangle, meaning it splits that opposite side into equal parts. So we need to find that median, and we need to find that coordinate. Then we're going to find the slope of the line using those points, the vertex and the midpoint, and then we're going to write the equation in slope-intercept form. So let's do this example together. First, we need to draw our triangle on our grid. So we're given the points. So P is at -5, 3. And Q is at 3, 7. And R is at 1, -3. So PQR, I'm going to connect the dots and draw my triangle. So step 1 was find the midpoint of the opposite side. If I'm looking for median RM, that means it's going to go from R to opposite side PQ. So I'm looking for the midpoint of PQ. So here's my x1, y1, and my x2, y2. And recall our equation for midpoint, x1 plus x2 over 2, y1 plus y2 over 2. So we're just plugging in those values like we practiced on the front page of our notes. All right, and that is going to give us -1, 5. So -1, 5 is that midpoint M. So that was step 1, find the midpoint. Now we need to find the slope using our midpoint and vertex R. So our slope is going to be y2 minus y1. So let's let M be our, so I'm going to label that point 1, 5. Let's let that be x1, y1. And R is going to be our x2, y2. So -3 minus 5 over 1 minus -1. So that's going to be -8 over 2, which is -4. So there's the slope of our line. So that's step 2. Now we need to find the y-intercept. So remember, y-intercept form, y equals mx plus b. We plug in an x and y value in our slope and solve for b. Well, here's an x and y value. So 5 is equal to our x value plus b. And then we just need to plug in our slope of -4. And we find that b is equal to 1. So that's step 3 now. Step 4 is just to write the equation. So y equals mx plus b, our m is -4, and our b is 1. So there's the equation of our line. Now a new topic we're going to talk about is showing that we have right angles on a graph. Now recall, the types of lines that form right angles are perpendicular lines, and we learned in day 1 that perpendicular lines have opposite reciprocal slopes. So if I have two lines with opposite reciprocal slopes, that means that they're perpendicular and therefore form a right angle. So if we show that two lines have opposite reciprocal slopes, we've shown we have a right angle. So let's look at these two scenarios here. First on the left, I'm going to label these sides A, B, and C. And the angle that could possibly be a right angle is this angle B here. So for that to be the case, CB and AB need to have opposite reciprocal slopes. So let's look at the slope of CB. It's a horizontal line, which means my slope is 0. And AB is a vertical line, which means the slope is undefined. So let's talk about what that means. A slope of 0. If I have 0 divided by a number, let's say 1 for example, that would be 0. Now the opposite reciprocal slope would be to flip it upside down and change the sign. Now when I divide by 0, that is undefined. So that verifies that the slope of a vertical and horizontal line are opposite reciprocals, and therefore B is a right angle. So a 0 slope and an undefined slope are opposite reciprocals. So B is in fact a right angle. Let's look at a different scenario though. Here in this triangle DEF, the angle that could possibly be a right angle is E. So for that to be the case, DE and EF need to have opposite reciprocal slopes. So let's find the slope of each and see if that's the case. Let's first find the slope of DE. So x1, y1, x2, y2, 7 minus 3 over 5 minus 2. That's going to be 4 over 3. So for the slope of EF to be the opposite reciprocal, it would need to be flipped upside down and negative. So we're looking for negative 3 over 4. Let's see if that's the case. Slope of FE. This is already x2, y2, so let's label this our x1, y1. So 7 minus 4 over 5 minus 9. That's going to be that's positive 3 over negative 4. And these are opposite reciprocal slopes, so angle E is in fact a right angle.